Okay, well, for users, this is mostly going to be for internals. You know how things work. Sysadmins, I will try by the end of the talk to convince that you should be packaging stuff. And for developers, that you should be packaging stuff too. So what is packaging? It deals with packages, deals with creating packages, retrieving it from internet sources, updating packages, and deleting. Here I'll talk mostly about creating and updates. And then I'll be talking about package managers. By the way, if people notice this, that's a database. That's actually how most package managers implement. They have a database of some sorts. And I'll be talking about related tools. So why package? Most of you will probably know once you get something, you do configure, make, install, right? Well, if you're a developer, you actually have to do all this to actually get the configure script. And if you're a distro, you actually have to do all that before you get a package. Get source, patch it, run through the whole auto tools chain, and then make check, make install, post install, do some stuff, configure, do stop your daemons, if any. So, but someone will say, well, those are just shell commands, so I can basically just make shell scripts. It will do, right? And that's actually, as we'll see, most other systems, they basically just make a nice wrapper around shell scripts. But deep down, they're all just shell scripts. So across distros, I'll be talking about Debian, Fedora, Gentoo, and Foresight. Just a quick survey. How many of you here use Foresight? How many of you use Gentoo? Gentoo, nice. How many of you use Fedora or Red Hat or derivatives? Me too. Cool. Debian, Ubuntu? Me too. Cool. So Debian, the tool to deal with single package is dpackage. There's actually dpackage, yada, yada, yada. And then for multiple packages, it's apt. The way Debian sees the shell script wrappers is basically says, why don't make it as a makefile? And that's what Debian/rules is. It's just a makefile. I think in the manual they say, well, you just need to make sure you have these 3 targets, build, binary, and clean. Build does all that junk, and then binary is the one that actually creates the deb for you. And if you're architecture specific, you get i386 or TPC. If you're independent, you get an deb.all.deb for Python sources and stuff like that. So yeah, that's how you make Debian rules from scratch. But if you notice before, makefile, there's a lot of repetition, and that was why we created configure in the first place. So yeah, so if we want to stick with that, then we might run into the same trouble of auto tools. You need all these mess to get around with it. So early on, they made deb helper, which the way I see it is it basically makes scaffoldings for you. You run dhmake, and then it generates a scaffold. If you're a Rails developer, you might know what I'm talking about. But it makes some files, and then makes some enough information to get you running, and then you have to fill in the pieces yourself. That's dhmake. And then there's a bunch of dh other stuff. So because most of the stuff that you're running are similar, but they have checks in them, so they wrap it in another script, which is great. So when you're doing deb helper, it auto-generates files. What happens is then deb helper itself increases version, and then the code that it generates from that version is different from the one the previous version generates. It all gets messy. So then some people thought, instead of generating code all over here, why don't we just refactor it? And apparently in makefiles, you can include another makefile, and that's how they go with the concept. So somebody made, all the functions needed for deb helper in debhelper.mk and just include it, and suddenly you can just say, oh, these are the basic stuff, and then the rest, just look at that file, it'll take care of it. So there is deb helper, and then there's CDBS, Common Debian Build Systems. They have basically refactored common code for patches, for auto tools, and for GNOME, KDE, XFCE. There's, depending on what desktop environment you're doing, there's extra stuff that you do in the end once you've finished compiling. And then there's stuff for Perl, Python, and for Java. So the problem is, well, if CDBS is great, all your common code is somewhere there, but what if I want to do something extra? Well, apparently Makefile, you can also, by virtue of it being a Makefile, you can just append it. So here you do build : so in your Debian rules file, you can just say include deb helper, but in the build, I want to do some extra. So whatever you do after : it gets appended to whatever the deb helper previously does. And if your Debian rules actually makes multiple packages out of one, this is how you separate. Oh, if you're building the server, do these extra. If you're building the client, do those extras. So there are other common stuff. So currently the CDBS is very small amount. The one in the 2 previous slides, that's mostly the common code. But we know that there is a lot of other stuff out there. Config, web apps common. I'll talk about this a little bit later. There's one for Mozilla extensions for Ubuntu. Can I have more, please? This is great. So for app, which is the multi-package dependency resolver, most of the information is in Debian control that has package metadata, name, author, copyright. And then there's build depends, what this package needs to build it. And then there's depends, which is what this package needs runtime, not build time. Because something you need to build, but you don't need it afterwards. And then there's conflicts, which says, well, if I got this installed, don't install that. And then there's suggest, recommends, which I think Synaptic drops by default, and then there's some other tools that installs by default. So if you want to package stuff for Debian, what do? Well, you make your own package archive. But I can never wrap my hand around it. It's around the right time, Launchpad started giving personal package archive, and that's what I've been using since. So you basically make your own stuff there. If you want to talk about gory details, come talk to me afterwards. I'm trying to give an overview of what the landscape is for now. But you basically upload your sources to the PPA, and then it becomes an app repo. You add it to your software sources, and it's good. Advantages and disadvantages. Depackage divert is pretty interesting. So for example, if this is an Apache package, and then one of the things that come with Apache is your configuration file. But most of the time when people, after they deploy Apache, after they install Apache, then they have configuration, and then when the next version comes, you don't want the Apache package to override that configuration file. So depackage divert can say, well, if next version of Apache comes, write it to this file, and then I'll do a diff and resolve it afterwards. That's pretty interesting. And then there's debconf. So because most of you use Ubuntu, debconf is when you're installing Java or VMware. This one pops up and say, do you agree to the license? Yes, or stuff like that. So this allows you to do dialogue while installing. And for sysadmins, you can use this to pre-manufactured answers. So then this will pop up in the shell, but then you already give it the answer and just goes. The disadvantage, from my point of view, packaging info is all over the place. I only talked to you about 2 files, rules and control. There's other files like install, which says copy these files here to here. There's the Debian Emacs and a bunch of other files. I think dhmake by default creates like 20 files or something like that. Can be better. Gentoo. This one is the one I did the most with. Single package is ebuild for dependencies. The tool is emerge. If somebody of you are using some C-optimized ones, there's Palutis. So what is a Gentoo ebuild? An ebuild is a shell script with functions. So you have functions like source unpack to get the source and patch, source compile that actually does the configure and make, and then there's source install that does the make install, and then there's source test which does the test and all that. And then there is package pre-install. So for example, if you make some application, this is the one that makes the new user and the new group for permissions and stuff like that. Then there's the actual merge, and then after that there's the post-install. What do you do after you install it? Like for GNOME packages, this is the one that registers, oh, I want to make the shortcut in the desktop menu, or scroll keepers, or man info pages. And then there's package config, which a nice example here is the Gentoo MySQL package. after you install it, you can say emerge --config MySQL, and then it will say, oh, you want me to configure? I'll init your database, ask you for a password. So you can do that for other packages for configurations after you install. So as I said before, there's pre-ins, the installation, post-ins. There is the mirror of that, pre-remove, and when you unmerge, there's the post-remove. So for portage, for multiple packages, there is the shell variable depends, which basically contains a string that says, oh, I depend on this and this and that. And then if you remember Debian conflicts, well, here conflicts is just a not package. That's how you'd say as well, don't install it with this package. And then there's rdepends, which is runtime dependency. Depends is build time dependencies. Initially, the plan was, oh, you can install enough to build, and then once you're done building, uninstall those stuff. But hasn't happened yet, but it's an interesting idea. E-classes. Initially, I said ebuilt are shell functions. Well, I lied. It's actually object-oriented shell functions. But so how does bash does inheritance? I'll talk a little bit, but there's E-classes for, by doing inheritance, you can do, there's E-classes for GNOME, KDE, almost most of desktop environments. And then there's stuff for languages, editors. These are plugins and modes. And these are actually package repos. So per module talks with cpan, gems talks with gem server, PHP pair talks with pair. So E-classes, the way it does it is it has a special function called inherit, and then these are the names of E-classes. And then you can say, oh, I want to inherit from GNOME 2 and Python, for example. And what that does is, into your shell script, it will import these two functions from the E-classes into the namespace. So then after you do that, you get GNOME 2 and GNOME 2 source unpack and Python source unpack. For example, GNOME 2 source unpack will have information says, oh, get GNOME from http://gnome.org or whatever. And then Python does its own things too. So the question is, well, what about source unpack now then? The answer is it's Python. So the one you do last is the default one, but you can always go to whatever it originally inherits. And if you want to do something on your own, then you can redefine source unpack, and then in there you call the other ones. Order matters. So notes, E-class like CDBS is just refactoring of common code. With that, there's actually E-classes for CVS packages, subversions. So these ones you can pull straight out of the version control and then do live e-builds and stuff like that. I like Gentoo because of this, but there's, I think Foresight does similar things. So another interesting thing that I want to talk about is how Gentoo dealt with web apps. The nice thing about web apps in Ubuntu or whatever is you install, say, WordPress. Done. But sometimes you want multiple instances of WordPress. Then how do you do it? Well, so you install one, the other ones you just unpack and get it from the web. The way Gentoo does it is it copies it into a directory, like user share, and then when you deploy an instance, it actually makes symlinks to var /dev/dev. Then you can say when, for example, WordPress gets updated, then you can say, oh, update all my instances. Or you can say, just update this instance and that instance, leave several alone. And then the web apps E-class is smart enough to say, oh, this file needs to be copied to every instance, and then the other file needs to stay within user share. It's pretty interesting. And earlier when I was talking about Web Apps Common in Debian, it's trying to do the same thing. So it's getting there. Then there's support for vhost too, but I don't do vhost, so I don't know what I'm talking about there. Another interesting thing is it pulls for gems and pair. The nice thing about this is it actually uses gems to do the gems. So once you install a gem, it actually shows up under the Gentoo package database. It also shows up in your Ruby normal gems. So then it don't step over each other's toes when you're installing things, which is great because I had a professor with Perl packages, and then you do cpan. Well, you install cpan from cpan, but you also have ones coming from Fedora, and they kind of fight with each other, and it gets messy. I think this is an interesting way to handle it, but for the way Gentoo does cpan is even more crazy. They've actually refactored enough code that all you need to do to make a Perl cpan e-build is just go to cpan, scrape the page, and generate an e-build out of that. So then they say, why do we need these? We'll just auto-generate them. For gcpan, actually, it will fetch any package from cpan, creates an e-build, and then puts it in your package. And so the Gentoo developers never care. Just say, oh. Interesting. So how do you do development for Gentoo? They work in overlays. The base overlay is user portage, and then usually the default one is user local portage. And then there's Sunrise, which is the staging before it goes to, usually if you file a ticket in Bugzilla, you say, oh, it's in Sunrise, look at this guy. There's GNOME, and there's other overlays in overlays, gentoo.org. Your overlay. An interesting thing also is for packaging development, most of the time you figure out the packaging one time, and then when you want to update your package, if everything else is the same, the way you version bump a Gentoo e-build is just you rename the file, and then the e-build says, oh, because the file name contains package versions, so then it will figure out, oh, that's the version, that means I go to the HTTP server and fetch this version, and all that. Ooh, I'm running low on time. Fedora, the one file is RPM. For multiple dependencies, you have yum or up-to-date or zip if you're running OpenSUSE or URPMI for Mandrake. RPM spec files is really just shell scripts with sections markers. So there's sections like prep, build, and install. And then there's macros. So in prep, for example, you do setup, which does the unpack and patching. And then in build, you have a macro called configure that automatically fills, put stuff in this directory with these flags. And install, have make install. Pretty similar. And then files is the section that actually says which files, after I compile stuff, these are the files that actually goes into the RPM, which is a little bit tedious because you basically have to say, you have to list every file that you build that you want to go in. Rust helps, but by default, just have a list of files, but then you can say, oh, this one is a document. You have special permissions, basically. You can say, oh, I want this one as 644 root or 755 or whatever. You can say default attribute if you're too lazy. Another nice thing is config, and then if you say no replace, then whenever there's a new version, it saves it in RPM new, and then you can diff it afterwards. As I said, Rust helps. This looks at the list and helps fill out the files. And similar to Gentoo, this one has pre, and then the installation and post, pre-on, post-on. And then, the introduction section of a spec files. It contains metadata, name, description. It contains also requires and conflicts, pretty much like the other tools. And then the nice things about spec files, which I just found out while I'm researching, is you have trigger install. So, for example, if I am some package and then I want to do bash completion, I can say trigger install bash. So then when another new version of bash is installed, then my package, which has a trigger in bash, will say, oh, once I know bash is updated, oh, there's stuff here too. And the same thing with trigger on. I think that's how it works. And then the other advantages of RPM is it's just mature. There's lots of tools. You have RPM to TGZ and Alien or Debian's RPMs. And then there's even apt RPM and other stuff. The disadvantage is, I think last time I talked to Linux OpenSUSE guy at the last Linux World, they don't share macros. So the macros I'm talking to you are mostly Fedora specific, but who knows what they're called in OpenSUSE? Who knows what they're called in Mandriva? Which is a little bit sad because they're all RPMs. It would be nice if we can all share. So hopefully that improves. Foresight. The single package tool is CBC, kinda. The multiple ones is Connery. A Connery package recipe is basically a Python class. You inherit from package recipe, and then you create this function called setup, and then in it you do pretty much the other stuff like add archive, pull it from here, patch, configure, make install, pretty standard. Or if those are not there, you can just run any command with r.run. Of course, you can be lazy and just inherit from out-of-package recipe if you're an auto tools, and then you'll just end up with a metadata, and the rest are taken care of for you. Well, you still have to do setup and archive because every package have different URLs, but that's pretty much it. So the super classes, there's auto-package recipe, there's also GNOME package recipe, KDE, CPAN, RPM. And then this feels kind of like the Gen2 class. Well, how do you do inheritance? No problem. Multiple inheritance is just a Python mixin. So, works. CVC. It's Foresight RPath actually sees your package repository as more like a version control repository. So if you want to make a new package, you do CVC new package. If you want to create a new one, you check out from the repository, and then you do your edit, and you compile, cook the recipe, and then once you're happy, you check it in. Well, I lied. It's actually a distributed version control. So, for example, you have the main Foresight tree, and then you can shadow like a package, copy the recipe out here, do your tweaks, and then once you're done, you can tell the developer, say, hey, I think I got a good package, and then if they look at the review and then say, that one's interesting, I'll just pull it back in. So CVC is quite interesting, and it, of course, does merges too in case upstream changes. Advantageous. It's Python. It's also following the distributed version control. It has rollback. So if you install something and decided, no, I don't want to install that, roll back. And it can roll back across multiple versions. So Synaptic tracks your history, but this one actually tracks history and make good use of it. Their packages is actually in change sets. So which is great for config files. It'll actually say, oh, I'm going to change your Apache conf file, but the diff only changes that part, so I'm going to just change that part and leave the rest the way you configured it. Interesting. Of course, I think they fixed this, but for a while, that also means that if you are Current is here, and well, if Current is here and you just downloaded and installed it yesterday, you have to download a lot of deltas to get there, and binary sometimes copies faster. But I think the new one is being taken care of. The disadvantages, there's a steep learning curve, I think. There's all kinds of lingo, like a throw flavor and stuff like that, that you really have to wrap your head around before you know the system. And the syntax, the verbose syntax to exactly specify a package is actually pretty hairy. It reminds me of Tom Lord's Arc, if any of you are known well. But I'll just leave it at that. But most of the time, if you leave out most of the parts, it does a pretty good way of guessing what you mean, and most of the time it just works. And it's relatively young, but I have high hopes. I'm going to tie up loose ends in whatever time I have. So for Chroot, it's usually helpful if you're packaging stuff to build stuff in Chroot, because, for example, if I want to help somebody package something, but it's really a package that just one time off, I don't want to install extra stuff in my real system, but I can have the Chroot install stuff in the Chroot and do whatever dependency. Debian has pbuilder, Fedora has mock, RPath has RMake, Gen2 has Catalyst. Well, Catalyst is actually a live CD creation tool, but it does it by doing Chroot, and you can use it for making normal packages. Build services. Ubuntu has a Launchpad PPA. You upload your package, you upload your rules file there, and then it does the builds for multiple platforms, and then in the end, it spits out debs, and you can just add that as your app repo. Fedora has Koji, which I think is just a build system. It doesn't give you, a yum repo or whatever. Our builder has our builder online, which is even more interesting. You can say, oh, build this. Oh, by the way, build this, not just a package, but all the way to a VM. So you can say, oh, PHP MyAdmin or MySQL. You can say, create me a VM that just contains all the packages needed all the way up here. Pretty interesting. That's how they build the whole distro, actually. And OpenSUSE build service is pretty similar. It's actually one of the earlier systems, and got one-click install. OBS is open source. You can hack this. The other ones are, I think, closed. Well, Koji is, withhold my judgment. And then what about Gen2? Well, there's a guy that's working on Tinderbox, but it's not really a build service. It's mostly for himself. And besides, the way Gen2 packaging does with use flags and the complexity explosion, it's probably not worth it. But if you want to build service, you can hack someone else's DCC farm. So devs, where do you want to package? It's a build system. And you can, and the way I like doing it is I do the test also in the build. So then it's a nice build system. It's great for checking out stuff out of SVN and making sure everything works and still installs just as a dev. And it's also a distribution system if you're doing PPA and OBS, for example. So you get nice bonuses. Sysadmins, why package? It's basically, I think of packaging basically as encoding best practices. So most people that I know, they say, oh, I compile my own Apache. Well, you don't need to just compile it in Apache. You can make an Apache package based on whatever the mainstream is, and then add your own tweaks, and then host that somewhere, and that becomes your organization's Apache package, which is much greater and get all the pluses from the packaging system. Same thing with, like, for example, installing web apps. People would say, write it in the wiki that says, oh, do this, 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 this. Screw that. Just make a package. So yeah, don't document package, or more like the package is the documentation. Users, why package? It's easier deployment. It's pre-built dependencies. Well, Gentoo got some pre-built support too. So what's next? I'm running out of time. Hang in there, guys. cPanism. So there's all this stuff. Should the OS distro handle all these stuff? If so, how? Do we want to do it like Debian manually? Or like Fedora? They basically do it manually and everything is outside of the system. Or do you want to do it auto-generated like Gentoo? The problem with the auto-generated part is, well, there's some other packages that is not Perl that needs the Perl package. So in the end, you still have to end up making your own package. There's 666 and more of these pseudo packages that just, oh, I just copied the description. So yeah, after a while, it gets hairy. Or maybe not. But if not, then how? And you have to remember that whatever solution we end up with this, we'll need it for Mozilla extensions and Eclipse plugins and other stuff too. So whatever we decide here might influence what we decide. What about Java? The current practice is you bundle jars, but then what happens is if upstream changes, well, then your bundled jars doesn't get updated. Gentoo is doing fun stuff, and then Apache Maven is another project that is doing XMLs or packaging. So nice to watch. Another nice thing is PackageKit. It's basically one UI to rule them all. People are making backends for all the other systems. Windows too. If I install Windows, Pigeon on Windows, I need GTK. If I install Xgen on Windows, I need GTK. GIMP needs GTK. And in the end, I have 3 copies of GTK in my system. So yeah. And KD4, I think, is going to be Windows application too. So there's something out there. And then yeah, for games, most of them need DirectX and extra stuff. So yeah, to watch. So things are getting better. There are many challenges ahead. Thank you. And I think I went over my time. Feel free to grab me after for Q&A, but I'll leave the room for the next talk. Thank you.